A one-port network includes RLC and dependent sources can be expressed as a form of impedance and admittance. That is, Z equals R plus JX or Y equals G plus JB. Because these two one-port networks are equivalent, the port UI relationship of the two networks are the same. U equals Z times I or I equals Y times U. Then we know Z and Y are reciprocal. We need to point out that Z and Y are reciprocal doesn't mean that R and G are reciprocal or X and B are reciprocal. You must remember this. With the concept of impedance and admittance, let's discuss the serial and parallel connection of impedance. In this circuit, Z1 parallel to Z2 and then serial to Z3, we want to solve the port equivalent impedance. We can easily get ZEQ equals Z1 times Z2 over Z1 plus Z2 and plus Z3. By substituting their value, we get that the result is 25.9 plus J 18.6 ohm. From this exercise, you can find that you should master the hybrid operation of the complex numbers with real and imaginary parts or modulus and phase angle in SS calculation. It's important to have a calculator with these functions. Next, let's discuss a little more complicated phasor graph. Let's have a review here. For resistors, U and I are in phase. For inductors, U leads I 90 degrees. For capacitors, I leads U 90 degrees. With the three basic concepts, we can draw the phasor graph of the whole circuit by the method of head to tail. In this circuit, the resistor is parallel to the capacitor and then is serial to the inductor. According to the previous discussion, you can find it's important to define the reference phasor in phasor graph. Here we define UR or UC as a reference phasor. They are the same. Then we know that IR must be in this direction. We need to point out that the magnitude of the voltage and the current of some element are not important while drawing phasor graph. We are concerned about the angular relationship between them. IC leads UC 90 degrees, so IC is vertical upwards. We are not concerned about the length of the phasor. Then we know IL is in this direction. Now we discuss the direction of UL. UL leads IL 90 degrees, so you may draw it here in this direction. Of course, it's correct, but do you still remember the method of head to tail? U equals UL plus UC. This is the starting point of UL. We draw UL in this direction and then get U. In this phasor graph, this is a current triangle and this is a vertical triangle. You will find it's easy to solve circuits with the method of head to tail in the following exercises.